now need to know how much fall do I need between this trench and this distribution box. How do I calculate that?
You need to know the length.
The length, right? And so how far is it from here to there?
4 feet.
4 feet. How much fall do I need in 4 feet? Every foot, I need what? An eighth of an inch every foot. So there's 4 feet, half an inch is what I need. And in the real world, I'd probably give myself an inch, right? Give myself a little fudge factor right there. Is if you leave yourself no room for error, you'll make error, right? So now, when we're going this way, we're actually going uphill, right? So we're going up this way. So which way does the receiver need to go? It needs to go down 1 inch. Do you guys see that one wrong move, going up when it should go down or down when it should go up, can mess you up? Draw a picture of these. Do a sketch on each one of these to keep yourself out of trouble. So now come to me. This shot right here represents the bottom of the pipe coming out of the bottom of the D-box. The bottom of the pipe on the outlet of the D-box now, right? So now I need to get to the inlet. What is the inlet separation between inlet and outlet in a typical D-box? About an inch, but it varies based on manufacturer, okay? But if we're dealing with a typical one, it's going uphill another inch because the inlet pipe is higher than the outlet. So which way does this receiver need to go? Down an inch. Don't move it yet until you move it, right? So go down 1 inch. And now move to the inlet end of the D-box. Inlet, invert. So now I need to get to the tank. How far are you from the tank? How much fall do I need between here and there?
5 foot.
5 foot. 5/8. What can I make that?
1 inch.
Let's make it an inch. Let's make it an inch. Once again, this is higher than that. You're going uphill, so go down with the receiver another inch. What I'm trying to do is calculate what is the deepest I can set this tank and still get gravity fall and fill up that whole ditch without anything backing up into this tank. So now this shot right here is the deepest the bottom of that outlet pipe can be and still get gravity fall to an 18-inch trench on this site.
That's the invert of the outlet.
Invert of the outlet. That invert means the bottom of that pipe, right? Hold this straight, Rod. All right. Something funny's happening. No, don't move it. It's right. You're almost right. The bottom of the outlet pipe to get fall is going to have to be almost on top of the ground right here. The tank is going to actually be about 12 to 13 inches taller than the top of that outlet pipe is. How high would this tank stick out of the ground to get gravity fall right here to this system? It's going to stick out of the ground a foot. Because when you're on shallow sites, on level sites where gravity gives you no fall, Eastern North Carolina, where are you at? Where's my Eastern guys go? Have you ever seen a tank sticking out of the ground? That is a common thing, right? Because they're trying to get fall to shallow targets. But what does that put pressure on me as far as a house stub out?
Hope it ain't too deep.
If this is a slab house, do I have a shot? No. It almost has to be padded up to make this work, right? And I'm a proponent that having tanks stick out of the ground on $500,000 plus houses looks bad for our industry. If I'm a homeowner and I've got a $600,000, $700,000 house and you've got me a concrete tank sticking out of the ground in my front yard, that looks like crap. And I put a pump in. I mean, and so, all right. So now I want you to work through here, and I'm going to show you where your stub out's going to be, and we're going to see if we can make fall. Because part of this process is not stopping right here and digging the tank, but part of this process is comparing it to the outlet stub out and seeing if we can get fall from there, okay? All right, so your outlet stub out is going to be on the ground right over there by that white flag.
Okay, so that's the other corner, that's the other side of the tank.
Yeah, that's the other side of the tank. You're exactly right. So you're at the outlet end, you need to get to the inlet end. What is the separation between 2 inches? Which way is that receiver going? Receiver's going down because we're going uphill 2 more inches, right?
It's 9 feet, right?
What's that?
9 feet about the length of it.
Don't worry about how long it is, it's 2 inches. Come stand right here. You're at the outlet end, and you could actually be on this side knockout. It's probably where we would come.
Might be the.
Yep. So now I'm coming to right here, and this, I'm gonna say the bottom of the pipe for the stub out's right here.
That is 9 foot.
9 feet. How much fall, plumber, do I need?
4 inch per foot. 9 feet.
9 feet. Technically, I could get in plumbing code with an 8 if we're skinning hairs.
But we like to have a quarter, not gonna lie.
Be generous and give the man 2 inches if you want to, but an inch and 8 would get you by if you were in a bind. But give him 2 inches if you want to. We're in trouble. I'm telling you, we're in trouble. Okay. And it's a very good plumbing stub out if it's sitting on top of the ground right here, is it not?
Yes.
That means this thing is padded up, right? So now you're right here, pointed at that receiver right there at the grade rod. You're okay right
We
there.
gotta go under the footer. I mean, you ain't got a choice.
All right. Come up, come up, come up, come up, come up. To get gravity fall, the bottom of the pipe for the stub out would have to be right there where the bottom of that is. Could he get fall to this if the stub out was on the ground here? Couldn't do it. Would not work. What would this system become? It would have to become a pump. But I've got guys that would say, hey, here's what we're gonna do. Let's just put this first line in at 3 feet deep and then we can get fall. Can we do that? No. Why did they give us an 18-inch trench bottom? Why? Some restrictive layer, some reason down there that they stopped, and we need to respect that, right? And so this is the process we would do. So I want you to back out the 2 inches and the 2 inches and to get back to right there. Okay, can you do that?
Yeah, 4 inches down.
So 4 inches down or up?
Yeah, 4 inches up.
4 inches up.
Well, I mean down going this
Yep,
way.
yep, down in elevation.
Up from
Up
here.
in.
If this was a real life scenario and this was a slab, wouldn't they just bury the tank and put it on the pump?
Yes, it would have to be. If it's a slab, we're done. This is a pump.
And even on the slab, you can't have a pipe sticking out from the wall.
Unless you're in outer base.
It's putting that right now.
All right, so now what I've got is we're back to this elevation. Let's just say the stub out was high enough and it worked, and we were ready to dig this tank hole. I know I've got all this, but how do I know what tank hole depth to dig right here? I've got to know something about from my tank manufacturer. I've got to know the dimensions of my tank. And you're going to start to know the dimensions of your tank by heart. In fact, tank manufacturers who want to sell tanks will provide you with cut sheets of their tanks, right? Have it laminated in your machine. And I know by heart that my tanks that we use in my area, we're going to see 52 inches or 54 inches on the inlet, but 52 on the outlet would be a common number for me from the bottom of the outlet to the bottom of the concrete down there.
To the concrete, but then we need the thickness of the
No,
concrete.
no, to the outside
to the
bottom.
outside.
Outside bottom.
52
inches is what I'm going to tell you it is.
Come on.
So which way is he going? He's going up 52 inches.
Hold on.
Snap it out, snap it out.
I got you. 52. I figured it is.
52 inches now. With confidence, make eye contact with the man on the machine and say, dig to this depth. Because this is the depth that if we dug any deeper, I wouldn't get gravity fall. This is deep as this tank can go and still get gravity fall and fill up that whole network and meet the rules. That make sense?
He does.
Start out there, work backwards, double check it against stub out, back here and dig your tank. All right? You can start at stub out, work out here, double check against lines, but mentally I like for the lines to rule my life.
Priorities
Because
there.
I can't move those. There are times, if it's a single wide trailer, can I raise the plumbing?
Yeah.
Absolutely, right? Can I lower that elevation on that drain line? No. No. The only conversations I could even have would be to go back to my soil scientist or to my permitter and say, hey, instead of using this top line, could I save that for repair and maybe drop down to the lower line to start my system? But many times we will not have the ability to do that. There won't be the room or flexibility to do that in the system.